So in this first video regarding the MedROC A-level organic chemistry playlist, we're just gonna be focusing on the introduction to hydrocarbons, which understanding will be a major step in understanding the main sort of features of chemistry. So we're just going to look at this organic molecule here, this organic compound, and the first thing you should sort of notice is both the only two elements that make up this compound are hydrogen and carbon. So before I go on naming these organic molecules, this does bring us onto the definition of a hydrocarbon, which is that a hydrocarbon is an organic compound or molecule. I'm sure no one's going to pick you up on that terminology, but that contains only carbon and hydrogen atoms. So say for example I have a alcohol here produced by this OH group. This is not a hydrocarbon because it contains this oxygen molecule right here. But anyway, these are the right here. I've previously drawn the first four hydrocarbons. Now, hydrocarbons is quite a vague term. These are all part of the homologous series of an alkane. Homologous series just being the sort of the family that different organic molecules and compounds belong to. So let's go along, start from this one and see about naming them. So first of all, we can see that there's one carbon and four hydrogens. Now what this means is the molecular formula of this organic molecule here is CH4. There is also one more thing I need to introduce you to, and that is the way to determine how a molecule is an alkane, and that's by using this general formula of CnH2n plus 2. So for example here you can see that this organic molecule has one carbon, so we can see here that N would equal 1. So we can deduce that the molecular formula is C1, but we typically don't tend to write 1 here. And H, so 2 times 1 is 2, add 2, which is 4. CH4. Now, the reason for the 4 hydrogens bonded to this one carbon is that if we look at the outer shell of the carbon atom, it will actually have an X here representing the electrons. It actually has 4 outer electrons, which means that the maximum number of bonds, the maximum amount of sort of elements that can bond to it is 4. So here we can see completely fully stable carbon is joined to the 4 hydrogens. So what sort of names can we assign to these organic molecules? Well, here this CH4 molecule is given the name methane. And we sort of see this methane accompanied with pretty much all organic molecules with this one carbon surrounded by its 4 attachments. Say for example we go back to our alcohol. This is called methanol. And so we see this sort of happening throughout all these different types of organic molecules. So here we have, obviously, let's find our molecular formula. We have our 2 carbons, so C2H, and then use this here. So 2 times 2 is 4, add 2 is 6. And we can also see that here, 1, 2, 3, 4, 5, 6 hydrogens. So what do we name this? Well, this is called ethane. And yeah, so you can see here that we've managed to work out the molecular formula of ethane using this general formula for alkanes. So what I'd like you guys to do is quickly find the molecular formula for this organic molecule here. So this is CnH2n plus 2. Use this. I'll give you 5 seconds here just to quickly sort of work this out for yourself. So this here, you can see there's 3 carbons. So we know that N is going to be equal to 3. So we have our first part of the molecular formula, C3. Now, because you can do this both ways. So because N is 3, 2 times 3 is 6, add 2, which gives us 8. Or we can count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. And here we come on to butane, which, as you've probably already guessed, has the general formula C4H12. So what comes after butane? Is there something that comes after butane? Well, after butane, the naming system actually gets quite a lot simpler. Say, for example, here we have our 5 carbon organic molecule. Just drawing these hydrogens in here. This is actually called pentane. You might think, oh, well, I could have guessed that because of this pent. You know, there are 1, 2, 3, 4, 5, the same as, say, a pentagon. Well, what would 6 be? And if you're thinking, what about hexane? Then you would absolutely be correct. So a molecule of 6 carbons and H would actually begin with hex. So a molecule of 7 carbons begins with sept. Hence a molecule of 8 is obviously oct, and so on. So say, and we'll go up to 10 here. So we have nonane, we have non for 9 carbons, and 10 carbons we have dec. So say we have a hydrocarbon with this C10H, well, it would obviously be 22 because we're using this CnH2n plus 2, so we've got 10, and 2 times 10 is 20, and 2, 22, and this, because it has 10 carbons, would be called decane, sorry, and we assign this ane because of its homologous series alkane, which has obviously the ending ane. So now that we know this, what is a hydrocarbon? The sort of idea of this video. Well, hydrocarbons are sort of these, obviously, you know, they're organic molecules. They're these organic molecules that are formed from large quantities of dead animals, which mostly consist of, you know, algae and zooplankton, plankton, that are buried under sediment rock. Now these have been buried for a very long time. So, and essentially what we have here, we have a fractionated column, And we have this term here called crude oil. So we'll get back to the fractionating column in a second, but essentially what crude oil is a mixture of all of these different types of organic molecules, or of all these different types of hydrocarbons. And you know, in these hydrocarbons we could have, say, butane, 4H10, we could have propane, C3H8, we can have octane, C8H 16, 18, you know, and they could all be in this. And because of the different chain lengths, and we'll get to this in a later video, but because of these different chain lengths, these hydrocarbons, these alkanes I've drawn here, actually have different properties. So you can see here that because of this heat, you have these like 350, 300 degrees, 260. These hydrocarbons can be separated by boiling point. And what this allows us to do is we can form all these different products. Say, for example, gas fuel, you know, sort of the smallest types, like, I don't know, ethane, can go right to the top here. Whereas these larger hydrocarbons are sort of lie down towards the bottom. You know, used to make these sort of roads, and as it even says here, bitumen and asphalt. So what's up here is these are the sort of shorter chain lengths, and these are the longer chain lengths. So this might be something like C12H26, and this might be something like, I don't know, like we said before, ethane. So C2H6. Now, what if we have a mixture of crude oil, but it's just full of long chain alkanes? Long chain alkanes, long chain hydrocarbons. Say we've got some octane. Say we've got some nonane, for example. How might we be able to obtain some shorter chain lengths from these longer chain length molecules? Well, I'm just going to introduce you to one last topic of this video that we need to discuss, which is called cracking. And I'll make a separate video on this as well. But essentially what cracking is, it's using a longer chain alkane to achieve a shorter chain alkane. And what this process actually does is, we'll put long chain alkane to create a short chain alkane, but it also creates another product here, because obviously, you know, where are the rest of your products going to go if this has a shorter chain? Well, we create something called an alkene here, which is essentially an organic compound which has a double bond around it here. Box isn't included. So, for example, I'll just draw the simplest alkene, which is ethene. And we'll go into alkenes in a different video, but it's good to know that from cracking you can produce a short chain alkene and an alkene. So say, for example, we have our nonane here, C9H20, and we don't want to have some sort of lubricating oil from this nonane. we want some petrol, we want some fuel. So what can we do? Well, we can crack it. Essentially what cracking is, you pass these hydrocarbons, this alkane, over sort of some powdered catalyst, some sort of catalyst at high temperatures, and this breaks the covalent bonds. And say from C9H20 we could sort of obtain C2H6, some ethane. And to fully balance this equation, to satisfy this equation, we'd obviously need a C7 and a H14. So you can see how this is not an alkane, because it does not follow the general formula. Instead it follows the alkene formula, CnH2n. Now, the one problem with cracking is you can't decide what shorter chain alkane you're going to create. So, for example, the covalent bond could break at any point in this. So you could end up with some sort of like C9H20, and we'll write the catalyst, and say you could achieve a C4H10, a butane, and to obviously satisfy this equation, C5H10. So this process is extremely random. Is random. So I hope this has helped you understand what a hydrocarbon is. Remember that it is just an organic molecule that contains carbon and hydrogen. But because of the strength of its covalent bonds, it is able to release a lot of energy as it is burnt, which is why it's used as fuels, and literally most of these are used for fuels, and it's because it has such a big potential of releasing energy. The only problem with this is, we'll get to combustion in a later video, but it does produce carbon dioxide and other harmful gases into the atmosphere. But hopefully this is sort of giving you an introduction to what hydrocarbons are, and hopefully you guys are here to stick along for the ride.